All right, so we are recording, but welcome everybody to, I don't know which tech talk this is. If Eve were here, he would know what number we're on. It's our first time though doing lightning talks, which is very exciting. So, and we're time shifting a little bit earlier because we have some folks on the call who are quite a bit east of where the group normally is. So one of our speakers is in Nigeria. So we're excited for that. So yeah, normally I would, well, I guess I'll give a little spiel about Collab Lab just for posterity's sake. It's on the recording and everything. The tech talks this tech talk is sponsored by the Collab Lab, and the Collab Lab is a nonprofit that offers remote collaborative project practice for early career developers. So the mission, what we do is we help early career people who are trying to get their foothold in tech by putting them on teams of 4 with professional web developers as mentors, and they work through a project over the course of 8 weeks. And they build an app together, and just we don't teach coding, but the whole point of the program is really to teach the like kind of get people familiar with how professional software teams work. So pair programming and writing a PR and demoing your work and doing all those kinds of activities that software teams do. And I know there are many, actually all of our presenters today are all either currently in or alums of the Collab Lab. So, and I know some of them have, Mindy actually has a little quote on our website about the difference that the program made to her, and I'm feeling confident going into kind of technical interviews and things. So, oh, Caitlyn is also quoted on the website. So yeah, so anyway, won't spend much more time on that, but super excited. This lightning talk format is kind of a new thing for us. So we're going to be 10 minutes for each speaker. I'll just quickly introduce people. They can start sharing their screen. They'll have about 10 minutes to both kind of present their material and, you know, answer any questions that you all might have. So maybe if an efficient thing to do would be to kind of queue up questions in the chat, and then when the person's done presenting, they can look at the chat, kind of answer questions there, and then we'll move on to the next person. So our first talk, are you ready to go, Rachel? I see a finger in the air.
No, I am now, because I'm using my mom's computer. Her phone calls are coming in.
Oh, right, okay.
It declined. So okay, I was like, okay. I don't know how to end it. Yeah, I'm ready now.
All right, so Rachel Fischoff is going to talk to us about caching on the client side.
All right, I'm going to share my screen.
You're doing a great job, Stacie, by the way, with admitting.
Okay, so just to give you a little background, I'm currently a member of the Collab Lab, and I was interested in caching. So from like a educational kind of like, Eve suggested that I give a talk on caching to learn more about it, which I found to be really exciting. But this is my first technical talk I've ever given, and I am nervous, but I'm going to do my best. All right, so we're going to talk about client-side caching. So first, oh wait, how do I? Yes, okay. So I'm going to talk, oh, I don't know how to go back. Oh, sorry, y'all. I'm trying to, I might have to stop this share. Okay, now I'm going to share again.
Arrow keys, maybe? Would that?
Yeah, that's what I was trying. It didn't do it.
All right.
All right, let me just, I see. Okay, I got it. All right, let me screen share again. Okay, so we're going to talk about what is it to be cache and cacheable, why use caching, what are some of the rules of caching, what are some examples of client-side caching, like private browser, shared proxy, and then we're going to talk about CDN, specifically Netlify, which is what we use to deploy for Collab Lab. Oh, here it is. Okay. And I have where I got all these definitions at the end in the resources, but this is from the guide on, what's it called? From like I'm so nervous. Roy Fielding's guide on what is like the HTTP protocol. All right. So cache is basically if like it's like to hide in French is like cache. So you're like kind of like hiding objects. So a program is oh my God, sorry y'all. This is so nervous. All right. Basically it's a program is local store of response messages that controls in a subsystem that controls the messages retrieval and deletion, and a cache stores cacheable responses in order to reduce the response time and the bandwidth for future equivalent requests. And it can be either a client or a server cache, but it cannot be a server that is acting as a tunnel. And so for a response to be cacheable, it's allowed to store a copy of the response message and answering subsequent request if it's like if it follows a certain set of rules, and then we can use that copy for the request. And just like the main, okay. And so a huge reason to do it is you're just like reducing latency and you're reducing network traffic. And so the performance of websites and applications can like be significantly improved by you reusing previously fetched resources, and web caches reduce like latency and network traffic, and then they less the time needed to display representation of a resource, which makes the web sources more responsive. We also think about it a lot in when we're like loading a bunch of assets, we're loading a bunch of images. If we have like what they call like a fingerprint of this that's already there, then we can load a lot faster. And so, yeah, it takes a lot less time for the representation to display it. And because the representations are being reused, it reduces the amount of bandwidth used by the client, which just like saves money and keeps bandwidth with requirements lower and more manageable. So yeah, you're just trying to improve performance. And then there's some definitions like a stored response is considered fresh if the response can be reused without validation. A fresh response can therefore be used for both to reduce both latency and network overhead. And so here are some rules of caching. So basically, a cache must not store a response to any request unless the request method is understood by the cache and defined as being cacheable. The cache status code is understood by the cache. And I feel like I reorganized this. And does not to appear in the no store cache directive does not appear in the request or response headers, or if there's a private response directive, it does not appear in the response. If the cache is shared, then the authorization header field does not appear in the request, and if the request is shared, unless it explicitly allows to. So the response, and these are just like what the response header has to contain according to like internet protocols. So if it's private, if it's public, and like you can find all this stuff on like MDN resources if you want to go into more details about like what the headers are. But there's a really good, there's this like a good flow chart to see if like how is it a reusable response? Yes, no, it's no store. Do we have to revalidate it each time? Yes, then probably no cache. Is it cacheable by media? And then it can be private or public. And then there's also a maximum cache lifetime. So you can put in a max age, or you can add a tag header, which are ways to do it. So when we're talking about client-side caching, we're thinking of both. There's like two types, a shared cache and a private cache. So when there's no cache, you can see the browser's just going straight, this first picture, to the web server. And so like all identical requests are going, even though they might have just gotten the same thing. So when you have a shared cache, the first it stores responses that may be used by more than one user, and they're usually part of an intermediary. Now, a private cache, in contrast, is like dedicated to a single user, and and so then this single is deployed as a component of a user agent. The two examples of that are a private browser cache, where it is dedicated to a single user. You can see caching your browsing settings already. If I knew how to share my screen a little better, I would just open up some JavaScript console and show you just how you can see different types of caching within just your development tools in your browser. And it holds all documents downloaded by the user, and it makes it so like the most visited documents are available for saving and viewing. And you can like you can see, I think Google uses it a lot for searches. There's like different ways. And then a shared proxy server is it's the shared cache that stores responses to be used for more than one user. And for example, an ISP or a company might have up a web proxy as part of the local network and infrastructure to serve many users that like popular resources that are used multiple times. And so the last thing we're going to talk about is like the content delivery network, which are CDNs. And that is what Netlify is using right now. And basically they're known as like reverse proxy servers or surrogate cache or gateway service. And so they're a little different than what we were saying. And yeah, so, so the example right now, so this, okay, so one good reason for making a modern website like static instead of a traditional site is that a modern static site can be hosted exclusively on the content delivery network. That means instead of having your site on one limited server, you can have your site on nodes all over the world. And this makes it really, really fast. It's like starting to load, it can be up to 10 times faster than a fully dynamic source, but this can also open an issue of what's called cache invalidation. Because on the CDN site is stored in your local cache, which makes it really fast, a lot of the files may need to be invalidated. And a lot of times this can take from like 10 minutes to several hours for your changes to be invalidated. So you'll have to wait to see it. Now, all CDN hosting services that actually cache sites, except for Netlify, make you do this. So Netlify is different. And so they're able to, for like assets like CSS files, JavaScript, or images, you can kind of work around that invalidation because they like rewrite the URL for the file each time the content changes, which is a practice of like asset fingerprinting. And so this basically can solve the whole cache invalidation issues that CDNs often CDNs often, it's not inquire was the word, that they have, that is like a problem with CDNs, and it can make it so that, yeah, it's a solution so you can have like a really fast site that makes sure that when you update it, there's not like the lag time and it's being deployed as we go. And so yeah, that is the that is the extent of the talk. I think I'm about 10 minutes.
Yeah, that was perfect.
Yeah, if anyone has more questions, we can talk about it later. So yeah, thank you everyone. I appreciate it. Very nice.
Yeah, good job. Well done. First technical talk. It's amazing. I didn't see any questions in the chat. Did anybody have anything that they were curious about or wanted to dig into, or? No? All right, cool.
I think a bunch of us said though that we really liked your visuals, that the graphs that you put in were, and the flow chart and all that were really, really helpful. Those
awesome. And I have a link to them all. It's either from like the Google or MDN. Like they're all just like from that. Yeah.
Cool. So and actually this goes for all the speakers, but if you have a slide deck and you're willing to, you can post it as a comment on the meetup page so people can go look at your slides later.
Sounds good. Thank you.
Cool. Awesome. Thanks so much. All right, next up, we're going to keep it moving. We got Yahaya Kehinde, goes by Kenny, who is going to talk to us about an application he built for the hospital where he works. Take it away, Kenny. You are muted in case you thought you weren't.
Sorry. Hi everyone, I'm Kenny, and I'm going to be taking us through an application I built for the hospital where I work. It's my first technical meetup, my first tech talk, so I'm also a bit nervous, but then I'll give it my best. So the application I built is a fluid requirement calculator that the idea came to me while I was working one night at work. So I think let me just go through the slide. So it's basically used to calculate the amount of fluid to give dehydrated infants as a result of many reasons, most commonly acute diarrhea disease. And okay, so the World Health, as a form of introduction, the World Health Organization defines dehydration as a condition that results in excessive fluid loss from the body. And in developing countries, especially like mine, it remains a major challenge, especially in children, and has major adverse effects that may lead to health problems if not efficiently managed. Um, in managing a dehydrated child, a significant part of the management is fluid replacement. And this is usually done by calculating the following parameters based on the body weight, the daily maintenance in meals, the daily deficits, and the total amount of fluid, which is calculated by adding the maintenance and the deficit. So in Nigeria, there's a shortage of health workers with most emergency rooms sparsely manned by a limited number of staff to cater for an unlimited number of patients. And as such, time saved in any form becomes a priority. And the idea occurred to me while at work on one of such days. So I was at work when a 2-year-old child was brought to the emergency room. She was unconscious, dehydrated, and having seizures. And I was charged with many responsibilities. So all of this time was of the essence. So I found it a bit overwhelming. I went home the next day wondering if there was a way to automate a few of the tasks so that when next I had a child with a similar condition, I had one less task to worry about. And these were the series of occurrences that led to the creation of the fluid requirement calculator, which at that time was my first JavaScript application. So okay, so this is like an image of what it looks like. So, okay. So basically, to try and explain how the calculation goes, it's a relatively long calculation. So the first thing we do is to calculate the maintenance fluid. It's usually calculated based on the body weight, and for infants less than 10 kilograms, the maintenance is 10 mils per kg. For children between 10 to 20 kilograms, daily maintenance is 1,000 mils plus 50 mils per kg for every kilogram above 10 kg. And for children greater than 20 kg, daily maintenance is 500 mils plus 20 mils per kg above every 20 kilograms. So to calculate the fluid deficit, this is usually done to replace ongoing fluid losses and usually calculated based on the degree of dehydration. So the degree of dehydration is gotten from the body weight, and it's gotten from clinical signs and symptoms, but it's broadly classified into two: mild, moderate, and severe. And this is the formula for calculating the fluid deficit. Now, these calculations have to be done manually in order to get the total amount of fluid. So what I did was, okay, to give some context. So let's assume we have an 8-year-old child who weighs 24 kilograms and has a moderate level of dehydration. So to calculate the maintenance fluid, we would have to first manually calculate it as the first 10 kilograms, which will give 1,000 mils, the next 10 kilograms, which would be 500 times 10, as 500 mils, and subsequent kilograms will give 18 mils. To get the total maintenance, I'm going to have a total of 1,580 mils, while the deficit would just be calculated using this formula. So body weight times percentage hydration times 100 in mils, this would give about 1,200 mils. So in order to get the total amount of fluid, we would have to add the maintenance plus the deficit, and this will give a total of 2,780 mils. Now, all these calculations would take a while, but then with the aid of a simple calculator, all these tasks would hence reduce the time it takes to calculate the total amount of fluids to give. And when I built this app, I initially built it to solve my own personal problem, and I decided to post it on Twitter just because because I felt maybe one or two people could relate, because it felt like, okay, it was a problem that some other people might also have. And within, I think, 6 hours, I had over 2,000 views, because it was really surprising, because a problem I thought was unique to myself turned out to be something that many other people had. And it has become routinely used amongst many of my colleagues in hospitals, and I'm just glad to be able to contribute. So this is an overview of the app. So this is, sorry, so this is what the app looks like. So in order to get the calculation, which we just did, all you have to do is just choose the level of dehydration. Let's simulate the example I gave. We said mild dehydration and the body weight was 24, and you click on submit, you get the exact same calculation, which is 2,000. I think I said 28, I'm not sure. Let me confirm that. Okay, 24, yeah. Sorry, okay. And then you get, okay, yeah. So you get the task automated, and you don't have to do all of the manual calculations. So yeah, thank you so much. I think I'm done. If you have any questions.
Amazing. Nice job, Kenny.
Thank you.
This is brilliant and so incredibly inspiring. Kenny, you deserve all the awards.
You deserve the
so
2,000 likes or whatever you got on Twitter. So how did you, I mean, I'm actually curious about two things. One is actually a sort of a technical thing, the medical thing of how do you, administering the fluids, is that like, do they drink water? Is that intravenously? Like what's
no, it's intravenously, yeah. So
okay.
Yeah, so when the child comes, the first thing you do is to set an intravenous access, and then you start to manually do these calculations. And then after that, you would calculate, it's over a 24-hour period. So then you would divide it usually 8-hourly when you calculate the maintenance and the daily fluid deficit. And then you would divide it over an 8-hour period, and then you give the child. So it's just basically to try and save time, and it's a rather small application in the real sense of things, but then it solves a really unique problem and makes work more efficient. So
how did you, I'm also curious, how did you kind of bootstrap yourself into being able to even build this? Like where did you learn the things that you needed?
So basically I'm really new to coding. I'm about a year into it. So my first experience was with Free Code Camp. So I went through the JavaScript sections, and I basically just Googled here and there until I figured out how things worked. It was my first application, so I'm not really proud of the code. But then I've tried a lot not to refactor it, because it reminds me of where I started from, and then helps me see how far I've come. So I'm quite shy to show the code base, but then since it was my first application, I just want to keep it as a reminder of, okay, this is how I started, and then at least I got it to work, really. So
yeah, that's amazing.
Yeah, thank you so much.
Well done.
Thank you.
Lots of props in the chat for you. Cool. All right, let's keep it moving. So Kenny, stop sharing your screen, and we'll move on to Caitlyn, who's going to talk to us about kind of introduction to AWS. It's a big topic. So I'm pretty sure I'm going to learn something. You're muted, Caitlyn.
There we go. Well, Stacie had originally said she didn't want to follow Kenny, and so I'm not saving lives or anything, but I did want to talk to y'all about AWS, because when last year I went through a coding boot camp and learned lots of Codybit things and did Collab Lab. I was in the first cohort. And that was all great. And then I got to my job and we use AWS to deploy our application. And I was just so lost. I was talking to a coworker about doing this talk, and I was just like, AWS is so much. And she was like, yeah, it's pretty much an ocean of like, huh? And so I wanted to reduce the huh as much for y'all as I could. So yeah, that's what I'm gonna talk about. So what is AWS? on the website, it defines it as on-demand cloud computing platforms and APIs for individuals, companies, and governments on a metered pay-as-you-go basis. So like, what does that even mean? It basically means that AWS gives you infrastructure, platform, software, and storage as a service. So it's kind of everything you need to get your application up and running. So my company uses it, and it's amazing. It helps people save a lot of money because you only use what you pay for. AWS has so many different options, and you can kind of just pick and choose and pay for only what you use. So why should you care? If you're not currently working at a company with AWS, or if you're an aspiring developer and you're like, I already have a lot going on learning JavaScript and React and Node and whatever, I get it. It might seem overwhelming, but there's over 1 million customers using AWS, and a lot of those are big Fortune 500 companies. And then a lot of smaller companies too. Like I said, in my company, we have like 60 engineers. We use AWS, and I am in a support role. We have rotating support shifts at work. So once a month, I am the person who, if something fails on AWS, I have to figure it out. Middle of the night, whatever. So I was surprised to find that I actually use AWS a lot in my job, despite having no knowledge of it to begin with. And then you can also earn sweet certifications and show off your skills. I love having little badges to like add to my resume and stuff. So that's nice because there's a big program for getting certified in AWS. So we're going to talk about some acronyms. These are super fun. Obviously, AWS is an acronym as well. And then here are a ton more that we're going to cover because acronyms to me were the most confusing thing when I started AWS because there's just way too many of them. So don't be scared. It's going to be okay. So first is EC2. This is Elastic Cloud Compute, or Compute Cloud, which means kind of nothing, but nothing to me at least. But it's basically the foundation of AWS. These are your servers. If you think of like using the cloud is putting your application on a server that's not physically in your office, or, you know, it's not something your company physically owns. It's in the cloud. These are your servers. EC2 is the computer that you're using. So one thing that's really nice about this and just AWS as a whole platform is they're scalable and secure. So maybe some days you just need one server and it can be small, and some days you need 500 and you need them to be big and use a lot. So like when you go to a public website like Netflix, they spin up an EC2 instance that runs all the Cody bits that you see when you look at Netflix, and this allows you to browse for hours without picking or watching anything. And that's kind of what EC2 is. It's the most common use is just web hosting. And you pay for only what you use. So regions and availability zones. Regions are basically geographical regions. So I live in Oregon. I'm in US West 2 region, I guess, and it's just geographical. And then within that region, there are 4 availability zones, and the availability zones make everything kind of more stable and secure. So say there's the availability zones are physical structures. So say I have my EC2 instance lives on a server that's in Portland, Oregon, and there is an earthquake and the whole building falls down, and I'm like, oh no, my website that everyone uses. But if it's in another availability zone, maybe it also lives on like the east side of Oregon or something, there's another building, my website will be okay. So pretty much everyone who uses AWS has their stuff in multiple availability zones so that you have backup at all times. So when we talk about, you know, these servers existing in the cloud, think of them as existing in a couple places. So S3 is simple storage service. And you'll kind of notice that AWS does this thing where SSS, it calls it S3, EC2 was ECC. So they abbreviate like that, and that can get complicated. But this is basically your storage. So you can store stuff where it's immediately available. So I kind of think of this the way I think about my closet at home. I have my t-shirts and my jeans immediately available because I need to use them like every day and pull them out of the closet. And then I have like, right now it would be like my summer dresses with flowers and everything. Like I don't need those. They're in the basement. They're somewhere far away. It would take me longer to get them if someone was like, please go get your summer dresses. So that's kind of how storage is on AWS. You can pay more to have things easily available, or you can just like put them way away in storage. And if you need them, they're there, but hopefully they're not something you need very often. And it's ridiculously reliable and secure, which is really nice. And it allows companies like mine, we make legal software. So we deal with legal matters, and you really can't have that stuff hacked into. That would be real bad. So we feel very confident storing our stuff on S3. RDS is the relational database services. This is just your databases. You can choose your own database engine and venture. They have Postgres SQL, MySQL, Oracle, regular SQL, and Aurora, which is a newer one. And they kind of handle all the things about databases that, to be honest, I don't know a ton about because I don't have to deal with it, which is really nice. They do the setup, the patching, the backups, and all I have to do is stuff information in there and then pull it back out when I need it. And again, scalable, reliable, no matter how much information you're putting on there, AWS will be able to scale up or scale down for you. SQS and SNS, these allow you to store and send messages. They kind of work together so that, say, if you have like, my company does microservices, and so if we have one service running and you try and ingest a large file, I'm able to watch in live time to see where that file is, like if it's progressing, and I can see if it fails. So another acronym is DLQ, which basically means like whatever you tried to do, it's like it died, it's dead letter Q, you're gonna have to rerun it or pull it out to, otherwise it'll just live there forever, which is bad. We don't want it to be dead. So it's a really great way to troubleshoot. When I'm on support, I use SQS all the time. I'm constantly just finding the things that got stuck or are unhappy for some reason and finding a way to rerun them and getting them back out. I think this is the last acronym, so stay with me. Elastic load balancers. So these help you manage the flow of inbound requests and direct traffic. So I kind of think of it as like a grocery store checkout. Like imagine if there was someone helpful kind of at the end of the checkout lines. I feel like they have this at Trader Joe's sometimes, where there's a bunch of people that are ready to check out and they're like, okay, you go to like station 1, you go to 2, you go to 3, and then they still have a long line and they're like, oh no, we need more checkers. And so they like ring the little bell and more checkers come up, and calling more checkers up is kind of like auto scaling. So it's really helpful because some days maybe only a couple people are on your website and you're like, okay, we got 2 or 3 checkers, this is plenty. And some days, like if you're a retailer on Black Friday, you need like the whole house up front to help and to manage the traffic. So Elastic Load Balancer is one of the ways that you save a lot of costs in auto scaling, because you don't want to have like 20 checkers in line at Trader Joe's for like the 7 a.m. shift when there's like 2 people in the store, but you do want them there for the big holidays. All right, and that's it. You survived, good job. Those acronyms might mean just like slightly more to you than they did 10 minutes ago. So at the end of my slides, which I'll link, I have some helpful links if you're like curious about AWS. It actually is a lot of fun, so I hope I didn't scare you, but here's some good links to learn some things.
That was awesome. Everybody loves your analogies, Caitlyn.
You need to write a book that's like coding explained through, I don't know what I'm not going to try and come up with an analogy to compete with what you've got there. You just need to do an explanation of coding in analogies. It was awesome.
Thanks, y'all.
So Zenzi had a really good question in the chat. So I'd love to know what your study schedule was for the associate level AWS cert. Did you find that the content easily fit with your accumulated programming knowledge?
So I had planned to take that test, and then COVID kind of threw me off, but I'm still planning to take it. But I think that like I've studied a lot just through using the platform, and to be honest, this presentation was a great form of study for me, because just because you can use it doesn't mean you can explain it. And yeah, I've used a cloud guru a lot to study, and my company has been very supportive in helping me find the time to like learn more about AWS because it is so relevant to my job.
Nice. Cool. And Sahil has another question. Any reason to choose another provider over AWS, or are they all basically the same?
They're not all the same, but I don't know that much about the other ones. I know one of the big benefits of AWS is the like very pay-as-you-go scale. So that, to my understanding, other than AWS, just seems to be the biggest one used, and they'll just bill you like by the hour and by the use, and there's such a variety of sizes. I think that's one of the benefits to a company.
Yeah, I'll add to that there are actually people have built services that will let you compare, for the equivalent features and the equivalent load and all that kind of stuff, whether Azure or even like Google stuff or whatever is cheaper than AWS. Like they'll let you compare the prices, so you can actually kind of dynamically move your stuff from cloud to cloud based on where you're going to get the best price. But cool, thank you so much. Excellent job. Next up, we have Stacie, who is going to talk to us. Yeah, that's right.
That's me.
You've done such a good job with admitting people to the
Thank you.
the call.
Thank you
but now you're going to talk to us about CSS grid area, how you shift elements around. So
I am going to do that for sure. Let me get things pulled up here. Full disclosure, I didn't make slides, and last minute was like, y'all probably need something to look at. So got some PDFs for you instead. All
right.
Anyway, so hi, I'm Stacie. Those last chats were incredibly profound and inspiring and technically insightful. So thank you all for sharing. This one is moving divs around a browser. So welcome to my talk. I'm going to share my screen with you. Okay, so what I wanted to show you today is a little bit how to use the grid to take elements inside your grid and place them wherever you want them to go, right? So by default, when you're using CSS grid, your elements are going to fall into the grid in whatever order you put them in your HTML. And from time to time, you might find that you need to move those into different spaces visually. They will be the same in the DOM, but you want to see them differently. And so we're going to see how grid template area can help us do that. So we'll take it a step back. What is grid? If you haven't used grid, you should absolutely learn it. It will make your life so much easier. But as you can see here in this very official description of grid, it is a super mega awesome CSS layout system. And what makes grid so special and amazing and powerful is that it is two-dimensional, meaning it can handle rows and columns rather than like Flex, for example, is largely one-dimensional. So very powerful, helps you create very beautiful and responsive designs. It can even make like, even the smallest things your life will improve with grid, like centering divs is something that you always see people on Twitter. How do I center a div? Just use grid. Make your life better, I promise you. Okay, grid template area, which is the star of the show today, allows you to take your elements that are inside your grid, give them names, and then put them wherever you want them inside the grid. So again, when you're using grid out of the box, your elements are just going to go in the order that you code them in. But if you want to move them outside of that order visually, you can use grid template area to make it happen. Why you might need grid area? That's a great question. And to be honest, I don't know why you might need grid area. I'm sure you'll find some way to use it. But for me, it's come in handy a lot in the past when a designer has handed me designs and they're like, here's like a grid of elements. And in desktop, we need them to be in this order, tablet, a different order, and mobile, an even different order. And I'm like, that's totally fine. We're going to use grid area to make it happen. And that's what I'm going to show you in a demo today. So on to the fun part where I actually show you. When I use grid template areas, I always feel like the director of a play who made a cast of characters, and now I'm doing stage direction and telling them exactly where I need them to be on the stage, exactly when I need them to be there. So in today's demo, we're going to be doing a little stage direction for a production of Sound of Music. Again, another PDF for you here. It's very advanced. Okay, so if you are a boot camper and spent a lot of time on Code Wars, like many of us are, this might feel very familiar to you, but I put together kind of like a fun little exercise that we will walk through. So based on the director's stage directions, that's us, there isn't a single order we could list these characters in an HTML to get the desired outcome. So we're gonna have to use grid area to shift these characters around the stage. So as the director, in desktop, the curtains are wide open. The cast should be in a single file line across center stage with Maria in the center. If you don't know Sound of Music, it's fine, you'll get the gist. In tablet, the curtains are starting to close. We want the characters to move into 3 lines with Maria in the center, the tallest kids upstage and the shortest kids downstage. And in mobile, the curtains are nearly closed, only a sliver of the stage is visible. We want everybody to go into a single file line, Maria downstage, all the children in order of age behind her. So you can probably just see from these descriptions that there's no order we can put these in to make it happen without manipulating those items in a different way outside of what order we're putting them in HTML. So let's take a look at what we need to do. So if you look over here on the right, direct your stage with grid template areas, you can see that there are 3 things that we need to do to make this happen. Build the stage, cast your characters, and then direct the stage. So let's start at the top. From the top, build the stage. We need a grid container. So the way grid works is that you have like a parent div, and on that parent, you need to set display grid, and that will make it a grid. Let me show you, let me find my cursor. There you are. So if we hover over this, you can see there's a grid here, and you can see this parent, the stage, has a display of grid. Great, check, we built the stage. Now we need to cast the characters. And the way that we do that is by using grid area. And just for simplicity's sake, I put it in line with the actual image, but you could put this in your CSS as well. So for each of the child elements of that parent grid, we need to give them a name. And we do that using grid area and then giving it a name. So this image I'm naming Gretel, this one Luisa, this one Maria, and so on. So we built the stage. Each of our characters has a name because that's the only way we're going to be able to tell them where to go. Then the final thing we need to do is direct the stage. We need to tell the cast where to go. And we do this by writing their names in the order that we want them to appear in the grid template area. So if I pop over to my CSS here, you can see that we have the desktop styles, the tablet, and the mobile styles. So we'll start with desktop. Again, the director wanted a single line across the stage, Maria in the middle, the rest of the kids doesn't matter. And because we only have 1 row, we only need 1 set of quotes because every row will need to be in their own quotes. So you can see them reflected over here in the exact order that the director has requested. Great. Okay, let's move on to the tablet view. As I shrink this, the curtains are closing. They're closing, they're closing. We need to go into tablet view. There we go. Okay, in tablet view, we wanted 3 rows. And so again, because each row needs to be in their own set of quotes, we have 3 sets of quotes with the characters in the exact order that we want them to go in. One thing to note here is that if you hover over this, you can see the grid. We need to fill each space in the grid with something. And so that's why over here on line 43, you'll see we're using dots to signify we want Maria in the center here, but nothing on each side of her. Alternatively, if you wanted Maria to stretch the full width, you could put her in each spot and she will stretch. That basically tells the parent grid you should expect the element that we're calling Maria to stretch across all 3 spaces of the grid. And then we go down into mobile because the curtains are closing again. Quick, get in a single file line. And there they are in their single file line. And we had mentioned that each row needs their own set of quotes. So in this case, each character gets quotes wrapped around them to make that single row. So there it is. That's how you can move things around. If you were to look in, let's just pop here. Your DOM will reflect these in the same way that we've coded them in HTML. So this is completely visual. So screen readers and other assistive technologies will get the original order that you have put in place. So that's how you do it. That's how you move things around. Using grid, I will share this code sandbox with you. You can do with it what you will. And you can catch me on Twitter at @TheRealStacie with underscores if you have other questions.
Yeah, awesome. I really loved this example using the stage. Good job. I have a
Bravo.
Actually, are there other questions in the chat? I had a question, but how do we get 3 Marias instead of 1 triple-sized Maria?
3 Marias instead of 1 triple-sized Maria. That's a really good question. I think that you would, I mean, like just off the top of my head, I would just put 3 of them in place, but I'm sure there's another way to do it that I don't know of.
The code that you used looked like you had, you said Maria 3 times.
Yeah, so what you're doing there, like on line 43, when I went Maria, 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 to stretch that 1 Maria across the whole thing, it's kind of like using an ID. You can only have 1 element called Maria. So when you do Maria, 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 it's only referencing 1 element and stretching it across all 3 of those spaces in the grid. But if you wanted 3 pictures of Maria, I'm not sure the best way to do that to answer your question, but just like a quick hacky way would be to literally just include 3 in your HTML. There's probably an easier way to do it, I'm sure.
Oh, I see. Yeah.
My question was just had to do with screen readers. So like a screen reader, I'm assuming no matter what the CSS does to the order visually, would still just read the things in the order that it's in the HTML. Is that your understanding?
Yep. I'm not sure how to make it reflect the visually manipulated grid in the DOM, but that is right that this will not change the DOM at all. This won't change HTML at all.
And then I guess Sahil was kind of asking if this is separate from Flexbox. Like what, like Flexbox and grid are related, right? But like, what do you see as the sort of differences between those?
They are both layout systems, obviously. The difference, and I don't know much about Flexbox at all, but Flexbox is one-dimensional, meaning I think it handles rows individually and columns individually, as far as I understand, but grid will handle both at the exact same time. So you'll be able to like have like a full grid rather than just rows and columns.
Yeah.
Does that sound right to anybody who knows Flexbox?
Yeah, I mean, I learned Flexbox first because it came out first, but it never really clicked for me. It was always very confusing, and it's an older API. It's less flexible, but some people think that they each have their use and like that they can and should be used together in certain circumstances. But like you were saying, like you've never really used Flexbox because grid kind of does all those things plus is with a simpler API. So, Brett, what you said in the chat that you use them together pretty often. So is there a use case where do you find it useful to use both of them?
Front page or home pages, especially when you're dealing with responsive design, I find that Flexbox and grid work together in screens that will actually adjust, like when you're changing portrait landscape mode in a tablet. It seems to work pretty well for that, in my experience.
All right, I should probably give it another chance, I guess.
I mean, give it a chance if you will, but honestly, like as somebody who also develops on the front end every day, I've never found a time when I couldn't use grid to completely solve a problem.
Yeah. Yeah, go for it, Brianna.
So can you use any character instead of a period to signify an empty cell?
No, I think that it needs to be the period.
Right.
I'm like testing it right now. I'm like, that's right, yeah. Stay tuned.
Yeah, I'm curious. That's a really good question. It could be that it's anything that's not designated as a, or not
no, that
already,
breaks it.
Oh yeah, it has to be the period?
Mm.
All right. Cool. All right, so that's some kind of like magic character, I guess. Awesome job. Thank you, Stacie.
Thanks.
Well
Thanks, everyone.
All right, we're gonna move on to Mindy, who's gonna give us an introduction to observability.
Yeah, all right, let me get my screen shared here. All right, here we go. So my name is Mindy Zwanziger. Short introduction about me. I am a former math teacher turned software engineer. I went to a code school called Launch School and was lucky enough to be a part of the second cohort of the Collab lab. Woo -woo. I started my first coding job in January of this year and then actually started working at a New Relic in July. So talking about observability, we really need to start with monitoring because it's definitely a big piece of it. And monitoring is basically asking the question, like, is it working? Is the app running? Is the server it's running on healthy? Are there a lot of errors? What's going on? We want to know if everything in the system is working well. And if not, we want to be alerted about it. We want to be woken up if need be. And we usually know kind of what could go wrong. We have a good idea of that. That's a piece of monitoring. So we kind of set up our code in a way to capture that information and get it to us in the best way possible. I'm going to sidetrack with a quick story here. Before I started working at New Relic in particular, I knew software engineers were sometimes on call. Like it's not always the case, but I knew they were sometimes. I'm like, I don't really understand why entirely. It turns out there's a lot of things that can go wrong for a lot of different reasons. An example, recently there was an issue where a subset of our users weren't able to load our software because of an outage in an external network. Luckily, we had set up some alerts to cover that scenario. We were able to page people and get it rerouted and get it fixed pretty quickly. Without those alerts and monitoring, our software could have been unavailable to people for hours. Like we wouldn't have any idea that that was even an issue. And there's this expectation, we all have it with our software that we use, the applications that we use, the websites we use, right? That it's always going to be available. We're going to be able to use it. And that's kind of the important piece of reliability. Like this should be accessible to our users. Otherwise you get mad. There's also sometimes a contractual expectation that I didn't realize was a thing until I started working at New Relic, that sometimes like the service needs to be available for a certain percentage of time each month even. You end up having to pay money back to users and customers and that sort of thing, which is interesting and crazy. Like reliability is a pretty big deal. So what that means is in monitoring terms, like just to give a kind of concrete example of what might go into that, we're going to do a really brief overview of some of the more common data types, just to give you some sort of a context here. We're going to talk about it in the context of a vending machine. So we have metrics, events, logs, and traces are kind of the four big monitoring data types. In terms of a vending machine, what that might look like, you could say a metric would be something like 3 people made purchases totaling $2.75 in the past 10 minutes. A metric is an aggregated measurement like this, where it's a sum or an average. Sometimes it's a numeric status. So let's say like the vending machine is 90% full. That is an example of a metric. We also have things called events. Events are an action that happens at a specific time. In this case, a purchase was made at 2:32 p.m. It was a purchase event. It occurred. And that is an event there. A log is often more granular than events. So we have this purchase that was made at 2:32. A log might have something included in it, like a user pressed the button B. You know, you're pressing B and then 4 and whatever. So that's an example of a log. It's something that's usually written into the code to kind of be a record of everything that's happened. I don't know if any of you, I know I did this or do this still, debugging stuff and doing console logs all over the place, trying to figure out where it is. Logs are kind of that way of figuring out where in the code you're working at. And then there's also traces, which are a causal chain of events. So we have this purchase event and that had a few different things that occurred within it. The vending machine contacted the credit card company, and then the credit card company contacted the issuing bank. Like there's kind of these pieces that make up the full thing. So being able to look at all of those different pieces is kind of what a trace is. So you'll hear the term instrumentation thrown around a lot in regards to monitoring. And what that means is setting up your code to collect and send all of this data somewhere. So actually, I don't know what I was gonna say next. Instrumentation, we'll move on from there. So in some circumstances, this really is enough. Like monitoring has been around since the 70s or even earlier. And it's a big piece of how we make sure that we have reliable software. But lately, in the last like 4 years or so, we've started seeing a new term pop up, which is observability. Why? What is the difference? Why are we looking at observability versus monitoring? And a lot of people connect the rise of this term to a change in how we build applications. But let's take a step back and talk about what it is. It's actually a technical term that's used outside of software engineering also. It was originally used in the context of steam engines, making sure that steam engines were able to be run efficiently and well. And the definition of it is observability is a measure of how well internal states of a system can be inferred from knowledge of its external outputs. So really, I mean, setting up monitoring seems like it automatically kind of means observability. We're instrumenting to get a look into the internal state of our software. So why do we separate the term and make it observability also? Like, there's a little bit more there. And that's because there's been a shift in how software is built. It's pushed the industry to realize we need more. We need more than what we've traditionally done in just traditional monitoring. A big piece of that is changing from monoliths to microservices. And a monolith architecture is basically like all of your code or most of your code is in one code base, and it's all you need to run the application. You deploy it all together. Any changes in front end or back end, it doesn't matter. It all is deployed in the same place. There's also microservices architecture, which is kind of like mini code bases, all talking to each other and getting the information they need from each other. And that's all deployed to make that running. And I kind of like to think of it as when you have a really large function in your code and you're like, this does way too many things. Let's break it up so it's in smaller pieces. It's similar with microservices. We're breaking it up into smaller pieces. There's a lot of reasons why people might do this. A big reason is actually talking about scalability. If you have like Caitlyn was talking about with the checkouts, right? If you have a really quiet day, you only need 2 checkouts. If you have a really, really busy day, you might need 20 different people. This is a similar idea where you can make it so that different pieces of your code can be scaled to larger sizes a lot more easily. There's also a lot of other pros and cons, but we're not going to get into all of those. The interesting thing, and here's a good description or good visual of it. We have the monolithic on the left side and microservices architecture on the right. You can kind of see how like some of them are talking to each other, some of them are talking to the UI. It can get really complicated, and it adds a lot of unknowns. Like sometimes you don't even know. You might be writing a service that you have no idea who's relying on it, because it just gets really big and there's a lot to it. And so that unknown is really pushing a lot of this change for observability. Charity Majors, who is the co-founder and CTO of an observability platform called Honeycomb, said this, and I felt like it was pretty telling. She said, when we blew up the monolith into many services, we lost the ability to step through our code with a debugger, and now hops the network. Our tools are still coming to grips with this seismic shift. So even thinking about so New Relic started as an application performance monitoring company. Like they are a monitoring company, and they've recently made this switch into observability because we've all kind of realized we need more. We need to figure out how to deal with all of this unknown amount of unknowns that are hanging out in our microservices and our cloud computing. So we kind of had to shift our mental model of how we observe our software. So ultimately, observability is the ability to ask questions about your system that you didn't even know you needed to ask. It's like being able to explore and find out exactly why and where there are issues in this huge world of unknowns. And so monitoring is a piece of it, and the tools that you use are a piece of it, and how those tools are structured is a piece of it. how you look at the code is a piece of it. Like it's a very broad term overall. And yeah, that's it. So that feel free to find me on Twitter. I'm also in the Collab Lab workspace. I'm happy to chat with people. Yeah, so.
Nice, very good.
Thanks.
Love that. Yeah, I've heard the term a lot, and I think you did a really good job of kind of explaining what the difference is between monitoring and observability. And that thing about once you move to services that have to talk to each other over the network, how important it becomes. One thing I was wondering, when that melt model, whether an event could be made up of multiple log entries, if that makes sense. Like I think of I don't know if this is quite analogous, but like a session, like a user comes to your website and they have a session that's made up of maybe several requests, and there's some parameters around if all the requests happen in a certain amount of time or without a certain amount of time elapsing between the events, then that's considered one thing. Is that the same in this world?
Yes, logs are definitely a part of events. Like I think they are made up in that way. I think there's, I think I missed the second half of your question. Shoot.
Oh, no, it's okay. I was just saying, yeah, like it seems like an event might be made up of multiple things that you might consider log entries. Is that?
Yeah.
Right.
Totally.
Okay.
Mm-hmm.
Okay. Cool.
Is it kind of arbitrary where you throw something, whether you categorize something as an event or a log or a trace? Like in a case-by-case basis, there's more than one right way to do it, and depending on how you compose things.
Yeah, I'd say so. I mean, there's definitely more than one way to do it, and it depends on how your team wants to approach it. I think is definitely there. I feel like they're instrumented differently. Like how you put it into your code is very different, and I think like the reasoning behind it is a little bit different usually. Like I think of logs as kind of showing the path of how you got to where you are, and events are like, this is a thing that happened.
So if you have an API for this, you'd have a create log API and a create event API and a create trace API, and they would do different things.
I'm sorry, I don't think I'm fully following the question.
Or I guess the alternative would be, you're just logging things and then the system is aggregating them into events and traces and that kind of thing? Is that more how it works? Or
they're not, it's not an aggregation process. I guess they are different. So typically what you'll do is you'll add an agent to your application tracks that. And I guess they are all working on different APIs, I suppose.
Mm-hmm.
Yeah. I mean, it is sent differently and different routes. It's not like you don't take all of the logs and aggregate it into an event.
Yeah, well, and you just mentioned like you would install an agent. So like that's the value that New Relic provides, or companies, similar companies provide, is they've encapsulated all that kind of all those business rules and everything into something that just you kind of install it and it takes care of all that stuff, instead of you trying to manually log all the things that would kind of make for a meaningful trace or something, right?
Yeah, I guess like I didn't think about the fact that you could create an API for each of those things to send it to a particular place, but that probably is similar to how the agents work even.
Mm-hmm.
I don't know, I'm not on the agent team.
It's all good. Cool. Thank you so much, Mindy. Did I miss any questions in the chat? Looks like, okay, I think we're good. All right, moving on to our last speaker. Lizeth Bañol is in Colombia, in the country of Colombia. She is in our first Spanish-speaking team for the Collab Lab. So she's actually going to give her talk in Spanish, but Liz, you have notes you're going to paste into the chat so people can kind of follow along as you make your presentation. But yeah, you're going to be talking about usability and user experience. So turn it over to you. Thank you so much.
Thank you, Andrew. Hi, my name is Lizeth Bañol. I study psychology, and I am currently in the work of marketing web developer. Yep. Bueno, les voy a la pantalla. Listo. Acá está. Bueno, hoy voy a hacer una pequeña introducción sobre lo que significa usabilidad. Voy a ponerle los subtítulos en el chat. Dame un momento. Ah, ya. Acá. Listo. Es decir, ¿qué significa que algo sea usable? Yo les pediré que piensen en la primera vez que ustedes tuvieron en sus manos un teléfono, un celular. En ese momento que tuvieron el celular, ¿ustedes cuántos años tenían? Tal vez, vamos a poner acá, ya. ¿Cuántos años tenían aproximadamente? ¿Entendieron rápidamente cómo se podía llamar del teléfono o se les dificultaba un poco? ¿Supieron cómo enviar un mensaje de texto? ¿O entendieron cómo se podía instalar una aplicación? Algunos de nosotros tuvimos un teléfono entre los 12, 18, 20, 30 años, tal vez. Esa variable debemos de, acá, ya. Listo. Esa variable tenemos que tenerla en cuenta en el momento de diseñar cualquier cosa, sea un producto digital, un objeto. Debemos de conocer los objetivos del usuario, su contexto y su modelo mental. En otras palabras, las circunstancias de vida que tienen las personas. Entonces, ¿qué significa que algo sea usable o no? Ya. ¿Qué significa? Pues que tenga una ausencia de frustración en el momento de interactuar con ese producto. ¿Vale? Acá. Aquí les voy a mostrar 5. Ahora quiero que volvamos al ejemplo del teléfono para hablarle de 5 componentes de la calidad de un producto que un producto debería tener cuando se está hablando de usabilidad. El primero es el aprendizaje. En el aprendizaje, a ver, por acá. Yo les pongo. Listo. Bueno, les preguntaba ahora qué tan fácil había sido entender el teléfono. ¿Qué les ha pasado si alguna vez han tenido pena de usar algún objeto delante de muchas personas porque no lo entienden muy bien? Por ejemplo, un microondas, una máquina de snacks, una cámara fotográfica, cualquier cosa. Don Norman, que es el padre del UX, escribió un libro acerca de la psicología de los objetos. Voy a poner acá, ya. Es un poco complicado esto. Ya. Escribió un libro acerca de la psicología de los objetos. Cuenta que una vez en un viaje que le ayudaba, estaba con una señora que le ayudaba en su habitación. Estaban intentando abrir un sofá, pero la señora pues se puso muy nerviosa porque no podía abrirlo, ¿sí? Entonces en ese momento ella le dijo, no, pues soy muy torpe para estas cosas. Él de inmediato se conectó con la sensación que le estaba produciendo esa sensación y pues pensó que a él le había pasado infinidad de veces. No somos torpes, el producto está mal diseñado. La segunda es la eficiencia. ¿Qué tan eficiente es mi producto? ¿Sirve para lo que debe de servir o mi cliente necesita ir a otra parte para poder solucionar sus problemas? La tercera es la memoria. ¿Qué tan intuitivo es mi producto? Si dejo de usarlo un mes, ¿podré recordar cómo se usa? La otra son los errores. ¿Cuántos errores aparecen? ¿Es fácil detectar el error y recuperarme de ellos? ¿O más bien me frustro cuando dejo a un lado el producto? La última es la satisfacción. Mi producto, cuando las personas usan mi producto, quieren usarlo o quieren recomendarlo, o simplemente pues ya no quieren saber nada más de él. Estos 5 componentes son realmente importantes porque de ellos dependen el éxito de nuestro producto. Acá. La usabilidad es como el oxígeno. No te das cuenta que lo necesitas. Bueno, perdón. No sabes que lo necesitas hasta que ya no lo tienes. Y quiero terminar ya pues con la paradoja de la usabilidad. Acá. La tecnología nos simplifica la vida al mismo tiempo que nos las complica haciendo productos más complicados de usar. Listo. Ya, terminamos. Finish.
Gracias, Liz. Muy bien.
Yeah, that's so great. Yep. I think that worked pretty well too. You put your notes in the chat. That was good.
That was smooth.
Yeah. Awesome. Were there any questions for Liz? Oh, nice.
Gracias.
Hay no preguntas.
All right. Thank you so much to everybody. Speakers, such a great job all across the board. Really love this. I just love seeing all the people from all over the world on our calls and everything. Thanks for being here. I guess that's it. And we'll see you next time.
Thank you all for coming. You'll be able to find this recording on YouTube later today, maybe tomorrow. So check it out. We host Tech Talks every
2 weeks.
Fill in the blank. Okay.
Yeah.
Every 2 weeks. So watch Twitter to see when the next one is. RSVP on Meetup and come join us.
Yeah, I'll post the YouTube link to the Meetup page, so you don't have to try to find it on YouTube yourself. And yeah, thanks for being here. Thanks everybody. We'll see you the next time.
Bye.
All right, take care. Gracias.